Okay, in this lesson we're going to cover 5.5 and 5.6. For now we're going to go ahead and skip 5.4. We can come back to it later, or we'll maybe cover some of that stuff in class. But we've already gone over some triangle congruence. We've gone over SAS is the one that we did in 5.3, which means side, angle, side. So in this lesson now we're going to cover SSS. So obviously since it's just S's, it means it's side, side, side. So when we're looking at proving these triangles, we're going to look at, all three sides, are they the same in both triangles? If they are, then we know the triangles are congruent. We also cover hypotenuse leg in this one as well. It's just one variation of side, 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 and so we'll get into it too. So like we said, side, side, side is just we're looking at our two triangles, our two sets of triangles, and as long as they have three sets of congruent sides, then we can prove that those triangles are the same. We know automatically that those triangles are going to be congruent. Everything about them is going to be exactly the same. So when we look at this, we have the statement here that tells us that if all those three sets of sides correspond and they're congruent, then we know that ABC is congruent with DEF. So just something we know off this, since if we are able to use side, side, side and able to prove that they're congruent, then once I know that from this triangle, then I can start to do my corresponding angles as well. So I could do angle A would be congruent with angle D. I would do angle B is congruent with angle E. And I could say angle C is congruent with angle F. Okay, I did not have to know this to start with, but since I know that they are congruent based on side, 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 now I can make these sorts of observations. I can be able to know, okay, well these are the same too, so now I can solve for them. And in this video, we're not going to do a whole lot of examples. We'll do a lot of stuff in class. But you do need to have all this information. You need to be knowing side, side, side means my three sets of sides are all congruent. Then we have hypotenuse leg. Hypotenuse leg refers to a right triangle. Okay, when we have a hypotenuse, typically we're talking about a right triangle anyways, because our hypotenuse has to be across from our right angle. It's our longest side of a right triangle. And so hypotenuse leg just tells me, instead of having to know all three sides, if I know that my triangle is a right triangle, so here we have our 90-degree angle, then all I need to know is the hypotenuse, the side across from my angle, and one of the legs. So if you look kind of here what it's saying, it says that so now we know that SAS and SSS work. Okay, we talked about side angle side in 5.3. Now we've said side, side, side works as well. And it says, what about SSA, side, side, angle? Can I know two sides and the non-included angle? Because remember, SAS, even though it's two sides and an angle, and SSS is two sides and an angle, SAS means that that angle is between my two sides. So like if I have an SAS triangle, say this triangle here, SAS would tell me I have these sides, and then I would have to have an included angle that's congruent. So if I have another triangle that's the same, to know that they're exactly the same triangle, I have to know that those two sides and my included angle, so side, angle, side, in that order, now I can know they're congruent to each other. But if I don't know, if I know the opposite, so say in this example, same triangle, and now I know a side, and an angle. Notice I just changed the side. I couldn't know whether or not these triangles were the same. So here a side, side, angle, side, side, angle. And in their example, they show you why. These two triangles, they have a side, side angle. Notice the tick mark. So we have BC is congruent with EF. We have AB is congruent with DE. And we have angle A and angle D are the same. But that last side can get extended, and it can actually change the length of that side. And so if the length changes, obviously we can look at these two triangles, and we know they're not congruent, right? They're not the same exact triangle. So that's why SSA does not work. But hypotenuse leg, though it's the same format like SSA, it works because now we know definitely that this angle over here is a right angle. And because it's a right angle, it actually fixes what the other two angles are possible of, what their measure could actually be. Because notice in this diagram to the left, I can't shorten this leg like in the other diagram. I can't shorten it and my hypotenuse still be the same length, right? It would go past it. Okay, hypotenuse leg just works because it's a 90-degree angle. It doesn't allow us to be able to change that hypotenuse in or out. So when we actually look at the theorem, like I said, you don't actually, as long as you know these theorems, now whether or not the understanding of the difference between SSA and hypotenuse leg, that part can get a little confusing. But you just need to know SSA does not work, but hypotenuse leg does, and so does SSS in this case. So here's hypotenuse leg congruence theorem. This is something you need to have in your notes, or you need to know where you can find it in your book. Notice the page numbers that it gives you, so when you're taking your test, you can look at them. But it just tells me if I have a right triangle, and I know the hypotenuse and the leg of that right triangle, then I know that they're congruent. So that's all it tells me. If I have my right triangles here, I have A, B, C, and I have D, E, F. As long as I know the hypotenuse and the leg, so the hypotenuse is our AB, it's our longest side, and our hypotenuse of DE, longest side, these are hypotenuse, both of them. Then as long as I know those are congruent and then one of my other legs, then I'm good, and I can automatically make the statement that ABC is congruent with DEF. We're going to go ahead and move on into 5.6. This just finishes out our congruence theorem. So we've had SAS, we've had SSS, hypotenuse leg, and now we finish out with ASA and AAS. Again, these are just used to prove triangles are congruent. This is it's like the bare minimum information you need in order to know that they are the exact same triangle. So here's the theorems for them. Angle, side angle just tells me that, again, they go in the order that they need to be on the triangle. So like if I were to start at one point and wrap around my triangle, my known information would have to go in the same order. So here I would hit first the angle of C, so I know that that's an angle. Then I go across the side, that's a side, and then my angle. So ASA, angle, side angle in this case. So angle, side angle is congruent. As long as I know that this information is the same, I look at these two triangles, I can say that those triangles are exactly the same. And then we have angle, angle, side. So we have two angles and we have the non-included side in this case. Basically, these are the same theorem. They both have two angles, but this one just tells us that in this case, as long as we know two angles and we know the other side, it doesn't matter if the side is included or not included, we can know that those triangles are congruent. So here we just have this summary of all the information. These are the triangle congruence theorems we've gone over. We have 5 of them. Okay, we have SAS, SSS, HL, ASA, and AAS. Okay, we do not have SSA. Okay, this one does not work. And we also do not have AAA. Okay, no SSA and no AAA. So in the examples below, we're just going to look whether or not we can use any of these theorems. If we can, then that means those triangles are congruent. If we can't, then that means we don't have enough information to prove they're congruent. Okay, it's possible that they could be, but we can only use the information that's given to us. We can't look at it and just say, oh, well, they look congruent, so they must be. Because remember, pictures aren't always drawn to scale. They might be barely off. So if we look at this first one of ABC, I'm going to start at A here, and I'm going to say I have an angle. Then if I go this direction, then I have an angle. I keep going around and around, and then I have a side. Okay, so in the order I said it, I have an angle, angle, side. My other triangle, it goes the same format, hopefully. We'll look at it. So if I start somewhere, if I start here at R, I have an angle. Then I go up here, I have an angle, then I go across, and I have a side. So it looked like they are congruent, okay, but the only thing I am going to double check is last time I started at A starts actually with the 2 lines on my A, so this time I'm actually going to start at Q, so let's try it. So if I start at Q, I have an angle, Then on this original one, I went up towards the one lined angle. So I'm going to go that way on this one as well. So I have angle, then I go to R, angle, I keep going around my triangle, and I get to a side. So I have angle, angle, side. So based on this information, I can know these two triangles are congruent because of angle, angle, side. Notice up here, angle, angle, side is one that actually does prove congruency. So we would be able to say these two are congruent. You could write a sign in there, or you can just rewrite your triangles are congruent to each other. Now we can look at the second one. So we have A, B, C. So I'm just going to go in that order of the one it starts with. So I have A. So A is an angle, a congruent angle. Then I'm going to go up towards B. B, I don't know anything yet. B, C, I don't know anything yet. And I come back. So all I got from this one was just angle, it looks like. I'm going to go to the other side. So this side, I start on the single one. So I have D, which is an angle. I go up, I go down, I come across. All I have is an angle. Okay, but in this diagram, maybe we can figure something else out. Actually, I missed one. We have an angle here as well, right? That right angle right there. This diagram, though, I can figure out some other information. Notice that I have a right angle here, and I have a line that comes across. Well, if I have a line, know that a linear pair always equals 180 degrees. So if this angle's right degree angle on the right side, it means on the other side it's also a 90-degree angle, which would make those two angles the same. The other thing you need to notice on this, we don't have any sides that are the same. Notice all of our things need a side. AAA does not work, but I need a side somewhere. I'm not told any sides are the same, but notice that they share this side in the middle. If the side is shared, obviously it's congruent for both triangles. If I were to split this triangle apart and I had it here and here, these two sides were the same because it's the same side originally. So they're going to be the same length even if I split those triangles apart. So when I have a shared side, I can actually say that that is a congruent side. So now let's try it again. If I start at A and I go up to B, I have nothing yet. I go down, I have an S. Then I have an A here, and then I come back. So that order was A, S, A. I do it on this side as well. So I go A, and I go down, I have an S, and then I have an A. So A, S, A. So I can show these triangles are congruent because of ASA. Notice up here, ASA is one of your ones that works. So these are congruent to each other. Go to number 5. So 5 has XYZ and JKL. So XYZ and JKL, I'm going to start on X here, and I'm going to go up. So I have a side. Then I go down, I have a side. Then I come here to an angle. So I have an SSA. On this other one, I'm going to go the same way. So I have a side, I have a side, and I have an angle. So SSA for both of them is what's congruent on those two. SSA, though, notice it's one of our ones that does not work, so that would mean these are not congruent. Okay, so 5 would be no. It's not possible to prove that they are congruent triangles. 6, this looks like another one. We're probably going to have to add some information, because notice there's only 2 things that are congruent in these triangles. So, remember that intersecting lines always make what we call vertical angles, and vertical angles are always congruent. So now we do have 3 things. Now we just need to see if the order is correct. So I have an angle here, then I have a side, then I come to an angle. I have an angle, a side, and an angle. So I have ASA. It is one that we can prove that triangles are congruent, so these would be congruent. It's important for you to know these theorems and at least have them down, so you at least need to have this table in your notes. And then, like I said, we'll be doing a lot of examples in class, and we'll be working on being able to prove these triangles congruent and being able to recognize them.